rewrite as multiplication. So I want you to write this down. Factor means rewrite as multiplication. Okay, factor means rewrite as multiplication. Step 1 is pull out the GCF. And again, there's a lot of words in here that I'd encourage you to read through, but I'm not going to read all of it to you. So in number 1, letter A, what is the GCF? What could I pull out of both terms? X. So I pull out an X, and I get 5X minus 3. I do not have to provide you an answer key to factoring, and the reason why is you can check them yourself. All I do is multiply it back out, and look, I did it right, okay? So I'm not going to give you an answer key for the factoring homework tonight. All right, letter B, what is the GCF here? What could I pull out of all three terms? 3x squared, right? There's a 3 that's common, so that's x minus 6x squared plus 5. All right, so recap quickly. Factoring means to rewrite it as a multiplication problem. Step 1 is always to look for a GCF. That's going to be our most common mistake. We're going to forget it. All right, yesterday in our warm-up, I reviewed a difference of 2 squares. I would like you to use your highlighter and highlight right here. A squared minus b squared factors into a minus b times a plus b. Note, a squared plus b squared does not factor over the real numbers. Okay, it does not factor over real numbers. Let me give you an example. If I do x squared plus 4, suppose you think that's x plus 2, x minus 2. Guess what? The outer and inner cancel, but that's not x squared plus 4, it's x squared minus 4. What if you think, oh, okay, then they both needed to be plus? That's x squared plus 2x plus 2x plus 4. This is why there's, I could do both of them minus and it's still not going to work, okay? So the big idea here is that a squared plus b squared does not factor over real numbers. If I wanted to get into the imaginary, I could get it to work. So let's look at number 2. It says factor each polynomial completely over the set of integers. So in letter A, I have x squared minus 9. So this is going to factor into x plus 3, x minus 3. Check your work when you factor. It works. I get x squared minus 9. The outer and inner cancel. In letter B, don't forget about the GCF. And here's a piece of advice. Anytime you look at a problem and you say, I don't know how to factor this, stop and say, did I get the GCF? Because 9 times out of 10, and I'm making that up, okay? Just making it up, but 9 times out of 10 if you forgot the GCF. Okay, so in letter B, what's the GCF here? 2x cubed. And then I would get 4x to the 4th minus 25. Oh, 4x to the 4th is a perfect square. That's 2x squared times 2x squared. 25 is a perfect square. It's 5 times 5. And think about our conjugates. Remember, conjugates got the outer and inner to cancel. The same thing is true with the difference of 2 squares. If you make them the same, but one a plus and one a minus, that'll get the outer and inner to cancel. So this should start coming back to you from Algebra 1, doing some factoring. Roman numeral 4, perfect square trinomials. You can live by never doing a perfect square trinomial. However, it makes your life easier if you'll recognize them. And you will notice it on the homework. If you're trying to do the A times C and you're getting like 300 something, stop and go, it's probably a perfect square trinomial. I'm not going to give you one that you have to do A times C that's 327 and adds up to 57. I'm not going to do that to you unless it's actually a perfect square trinomial and it's easy to do. Okay, so as you do some of those, you got to just tell yourself, this is McInerney, does not do that to me. So I need to think of something else. I'm not in the business of torturing students. That's not my objective. So here is a perfect square trinomial. If you have a squared plus 2ab plus b squared, I can factor this into a plus b, the quantity squared. Likewise, if I just change it to a minus in the middle, it does that. So let's look at number 3 now. Remember step 1, look for the GCF. What's the GCF here? There's a 3. What about the letters? They have an H and an S. So that gives me 4u squared plus 12ua plus 9a squared. Haha, the UA high school, UA high school, get it? Okay, so now we have to check for the perfect square trinomial. 4u squared is 2u being squared. 9a squared is 3a being squared. Now here's what the 2ab means. This is 2 times 2u times 3a. Does that multiply to the 12ua? Yes. So this is in fact a perfect square trinomial. And if we need to, tomorrow I can put a little bit more perfect square trinomial. That's one that bugs students. And again, do you see I could have done 4 times 9 is 36 and adds to the 12. I can do that. But when they get to be really big, that's painful. So that's my final answer. And this emphasizes why this is not 2a squared plus 3a squared. There's a middle term. Okay, there is a middle term. Okay, in this letter B, 25x squared plus 10x plus 9. Is there a GCF? No, there's no GCF. So I'm going to go directly to see if this is a perfect square trinomial. It looks like maybe it is, because it's 5x being squared, 3 being squared. Now I have to check the middle. That's 2 times 5x times 3. Uh-oh, is that 10x? No. And if I did 25 times 9, there's no combination that works. When this happens, it will happen sometimes that you cannot factor, like there's no way to factor it. We call that a prime polynomial. It just does not factor. So this one didn't factor. All right, Roman numeral 5. We've done this one quite a bit this year, so hopefully this one will be easy for us. If you have x squared plus bx plus c and a is 1, remember this? If I have x squared plus 19x plus 48, I'm looking for two numbers that multiply to 48 and add up to 19. So what I want you to notice is you can make an organized list and find the magic pair. And then once you find it, you just pop it in, x plus 16, x plus 3. So I'm going to pause a moment, and I want you to try number 4, A, B, and C. Find two numbers that multiply to positive 20, but add to negative 9. Once you find them, you pop them in. All right, who can tell us their factors for letter A? Jared, what'd you get? Negative 5, negative 4. So you write it like this. X minus 5 times x minus 4. How about letter B? Somebody different. Who can tell us what two numbers? Yeah, Gracie? Awesome, you got it. X minus 4, x plus 3. And this last one, this one was a little bit harder to do. You're looking for two numbers that multiply to 60, but add to 17. Anybody else? Paula, what'd you get? Say it again, a little louder. Good job, 12 and 5. This one was a little bit harder to do, so that's where you've got to like make a list and try them. Okay, so now let's take it up just a notch. What if there is a number in front of x squared? Then we're going to do what's called split the middle. And so if you look at this one, if I have 4x squared minus 11x minus 3, I'm looking for two numbers that multiply to negative 12, but add to negative 11. So that would be negative 12 and 1. So what I'm going to do is I'm going to rewrite the middle term as negative 12x plus 1x and split the middle. When there's no number in common, we just put a 1 out front because that's true. And for my advanced students, I want you to see what I did over here. This is called trial and error. So those of you that are very advanced and you're definitely going to pre-calculus, I would like you to try this trial and error, okay? Where you're looking at the factors of 4 and you're looking at the factors of negative 3 and you just do a little guess and check until you come up with them. It's way faster. And this is only if you can really handle this, and this makes sense. So I'm going to get you started on 5A, then I'm going to pause and let you try these. So I'm looking for a product of negative 12, but adds to positive 1. You take the A times the C, the 2 times the negative 6, and it adds up to the B value. So this would be positive 4 and negative 3. All right, I'm going to pause, let you try. And then go on to B and C. And if you're working on the trial and error, you would put 2x and x and just do some guess and checks. Remember that you write down the middle operation sign, and when that middle operation sign is a minus, Notice that that flips the last sign. Anytime the middle operation sign is a minus. So I get x plus 2 times 2x minus 3. Is it okay to have those factors flipped? Yes. Why is it okay that I could have the 2x minus 3 first? Like, why is that okay? The commutative property, like 5 times 9 is the same as 9 times 5. So the order doesn't matter. All right, keep working on B and C, and then we're almost done. Letter B, you're looking for two numbers that multiply to negative 30 but add to negative 7. Can somebody give me the magic pair that would work if you're doing it this way? Good job. Negative 10 and positive 3. So I'm going to go 5x squared minus 10x plus 3x minus 6. Remember to check your work when you factor. X times 5x is 5x squared. The outer is 3x. My inner is minus 10x. That adds up to negative 7x. Negative 2 times 3 is negative 6. It works. I'll pause in case you're not done with letter C yet. Excuse me. So I'm looking for two numbers that multiply to positive 60, but when I add them, I get negative 16. So I came up with negative 6 and negative 10. So I'm going to do grouping. So I pull out a 2x and get 2x minus 3. Write down the middle operation sign. That's a 5. So I pull out 2x. Notice it becomes 2x minus 3. Check your work when you factor, because you will catch the silliest mistakes if you just check your work. All right, any questions on this? We've reviewed this year, remember? So I'm just trying to make sure you have solid foundation for factoring. In chapter 6, we're going to cover polynomials. And when we do the polynomials, we're going to do higher level factoring, okay? So I'm just really trying to build a solid foundation for us. Questions? Is this review? Yes? Yeah, okay. Grouping. Grouping is when you have 4 terms. So I want you to do A, B, and C, but then pause. Okay, pause on B, because that one has a little bit of a tricky part to it. And C does have a little trickiness, but I think you can do that one. So try A, B, and C. We've been doing grouping the whole time with the split the middle. So So here's letter A. I factor out the x and get x plus 4. I write down the middle operation sign, pull out the y, x plus 4. So we remember how to do that. Okay, keep going. All right, letter B. I'm going to pull out the 3x squared and I get x plus 1. You write down the middle operation sign, and then do you notice they don't have anything in common except 1. They do have a 1. I know this one bugs students. So it really does, and then it becomes x plus 1 because I pulled the minus out. So I get x plus 1 times the quantity, 3x squared minus 1. All right, letter C. My GCF is 2x, and I get 2 plus 3y. I write down the middle operation sign, I pull out a 3, and I get 3y plus 2. Now at first you might think, uh-oh, they're not the same. However, they are the same. I have the commutative property for addition that says 2 plus 3y is in fact the same as 3y plus 2. And I want to pause here a moment to have you listen in. If I have 4 plus 7, that is the same as 7 plus 4. But 4 minus 7 is not the same as 7 minus 4. So subtraction is not commutative, but addition is. Now I can finish this one. So 3y plus 2 times 2x minus 3. Any questions before we do the last one? This one goes up another level. Questions? All right, letter D. Guess what? There is a GCF across all 4. Step 1 is always, always, always pull out the GCF if you have one initially. So I'm going to factor out the t and get 2xy plus 2cx minus 3y minus 3c. Step 1 is always pull out the GCF. Now, on the inside, I can do the grouping. So I can pull out the 2x, and I get y plus c. Write down the middle operation sign. It's a 3, y plus c. Now, the only reason why I'm putting this funny bracket is because, and you could use parentheses, any sort of grouping symbol is acceptable, but I did the bracket just so that I wouldn't get confused with my other parentheses. That's all. Whoops. There we go. I'm back. So then I can drop them and just say it's t times y plus c, 2x minus 3. And that concludes the notes.